What if everything we thought we knew about how galaxies and black holes formed is wrong?
Right now, 11.9 billion light-years away, a mysterious red object nicknamed the Cliff is shining back at us.
It's not a galaxy.
It's not a quasar. It may be something astronomers have only imagined in theory, a black hole star. And if that's true, it could rewrite the story of the early universe.
Today, we'll break down 3 things: the discovery itself, what makes these little red dots so unusual,
how the black hole star idea could change our picture of cosmic evolution forever. Stay to the end. The evidence for the cliff is unlike anything the James Webb Space Telescope, JWST, has sent back so far. When JWST began science operations in 2022, its infrared eyes were designed to look deeper into space, and further back in time, than any telescope before it. Within months, astronomers began noticing something odd in the data: tiny, compact, bright red points scattered across the distant cosmos.
They quickly earned the nickname Little Red Dots.
At first, these dots seemed like galaxies, but the numbers didn't add up. If they were normal galaxies, each would have to pack hundreds of billions of stars into a volume far denser than even the Milky Way's core. In other words, impossibly massive and impossibly dense for such an early era of the universe. To figure out what these dots really are, astronomers turned to one of their most powerful tools, spectroscopy, splitting light into its component wavelengths to reveal the fingerprints of the source. The Rubies program, launched in 2024, gathered spectra from thousands of distant galaxies. Among them were 35 of these little red dots.
One, in particular, stood out. Astronomers nicknamed it the Cliff.
Its light had traveled 11.9 billion years before reaching us, showing the universe as it was only 1.8 billion years after the Big Bang. It displayed an especially sharp Balmer break, a sudden jump in brightness at certain wavelengths. Balmer breaks do occur in normal galaxies, typically indicating older stars.
But the Cliff had a break far steeper than anything known.
Researchers tried to fit its spectrum using existing models, dusty galaxies, active galactic nuclei, even hybrids.
Nothing matched.
It was unlike any galaxy or quasar ever observed. Despite the name, it's not a star in the traditional sense.
At its heart sits a supermassive black hole surrounded by a bright accretion disk. What makes it different is a thick, turbulent gas envelope shrouding the entire system.
This envelope acts as both a mask and a filter. High-energy radiation from the black hole is absorbed and re-emitted, producing light that is compact, red, and marked by the unusual Balmer break we see in the Cliff.
In other words, it shines like a star.
But its core is a feeding black hole hidden inside a cocoon of gas.
This concept had been explored theoretically for years.
Some models predicted that the early universe might produce these gigantic quasi-stars, objects tens of thousands of solar masses with black holes at their cores.
But until now, there had been no strong observational evidence.
Some black holes in the early universe are already billions of solar masses just a few 100 million years after the Big Bang. Black hole stars could be their seeds, rapidly feeding black holes hidden inside enormous envelopes of gas.
Because we're not seeing entire galaxies. We're seeing single, massive objects radiating through thick shrouds of gas.
It suggests the early universe may have gone through a phase of exotic object formation, a stage of evolution we've never directly observed until JWST. If confirmed, black hole stars would rewrite textbooks on how galaxies and black holes grew up together. Of course, extraordinary claims require extraordinary evidence. Astronomers are now testing the black hole star hypothesis with more JWST data and with upcoming instruments. Spectral signatures unique to gas envelopes absorbing and re-emitting black hole radiation. Variability patterns that differ from normal galaxies or quasars. Gravitational lensing opportunities where foreground galaxies magnify these distant dots for closer inspection. If multiple little red dots show the same steep Balmer break and other predicted features, confidence will rise. And if the data matches the models, the Cliff won't just be a strange outlier, it will be the first member of a whole new class of objects.
This is why the discovery is so exciting.
JWST was built to answer big questions about the first galaxies. Instead, it may have opened a window into something even stranger, the birth of black holes inside colossal, star-like envelope.
Future telescopes will push this further.
NASA's Nancy Grace Roman Space Telescope and ESA's Athena X-ray Observatory will provide complementary data. Even gravitational wave detectors might one day pick up signals from the collapse or merging of these early monsters. And, of course, JWST itself still has years of observations ahead. Every new survey could reveal more little red dots, each a potential black hole star waiting to be studied. So why should you care about a faint red dot 11.9 billion light-years away? Because it challenges our most basic story of how structure formed in the universe. Because it hints at processes powerful enough to seed the gigantic black holes at the centers of galaxies like our own Milky Way. And because it shows how a single telescope, with the right technology, can overturn decades of assumptions overnight. If the cliff is truly a black hole star, it's not just an astronomical curiosity. It's a message from the dawn of time, a snapshot of a phase of cosmic evolution we never knew existed. The James Webb Space Telescope is still young.
It has already delivered stunning images of galaxies, nebulae, and exoplanets.
But sometimes, buried in its data, are quiet signals that change everything. A cosmic puzzle piece from 11.9 billion years ago telling us, the universe had stranger beginnings than we ever imagined. If you love deep dives into discoveries like this, subscribe and tap the bell icon. It genuinely helps us bring you more groundbreaking science stories from the edge of space and time. Thank you for watching my channel.